The video describes the implementation of a dynamic MPTCP-driven failover mechanism between terrestrial and non-terrestrial networks. The first step in the process is to start the MPTCP client. Once the client is running, the MPTCP server is initiated, followed by the launch of the IPERF server, which is used to generate network traffic. The overall network topology is visualized through a dedicated web-based user interface. For the non-terrestrial network NTN path, we begin by starting the three essential components of the OpenSAND emulator, namely the satellite, the gateway, and the terminal. Traffic is being initiated from a 5G connected UE, which acts as the client. Using the IPRF application, traffic is sent and can be monitored on the Amarisoft 5G dashboard. By default, the terrestrial path is selected and traffic is transmitted at a rate of 10 megabits per second. Traffic monitoring is available both through the terminal and the BM-on tool. Initially, no traffic is observed on the non-terrestrial path. Once the NTN path is selected as the primary route, the traffic is redirected accordingly. This change is clearly reflected in the terminal and the BM-on tool, confirming that the traffic is now flowing through the NTN path. Afterwards, we split the traffic between the terrestrial and the non-terrestrial network by selecting the relevant button from the web UI. The splitted traffic now is being measured at approximately 5 megabits per second for the TN path and 5 megabits per second for the NTN path accordingly, since the original limit for a practical throughput for TCP over high-latency links is 10 megabits per second. Then we stop the traffic from the IPRF application, running at the 5G connected UE, and through the dashboard of the Amarisoft 5G, we can see that all the logs are stopped, thereby terminating the experiment.